All right, we're gonna take a look at converting polar and Cartesian coordinates because you got to be able to go from one to the other. All right, so let's graph this point and convert it into the polar coordinates into rectangular form. So I need a radius of 3 and I need positive pi over 2. Pi over 2 is right here because it goes 2, 3, 4, skip 5, 6. So it's on this line. So boom, and 3. So a radius of 3. So let's just say 1, 2, 3. So this point right here. Okay, so that's the point that we have graphed. What is the x value? All right, so what's the x value of this point? If I was doing this in terms of x and y, this would be 0, 3. So this would be 0. The y value would be 3. So in rectangular, you'd write 0, 3, correct? So now so we could do that because that was relatively easy to do, but sometimes it's not as easy to do just by drawing it. So what you have to do is figure out how you can use formulas to do it. So remember SOHCAHTOA. So again, from a previous video, if this was theta and this is the radius, this is the x value and up is the y value. All right, so if it was writing cosine, which is a over h, so this would be O, this would be h, and this would be a. All right, so cosine would be a over h, so a, which is x, over h, which is r. Okay, it's saying therefore x equals, so it wants us to write this in terms of x equals, and all I do is multiply both sides by what? R, right? So this will be multiplied by r, the r's cancel out, leaving x equals r cosine of theta. I'm going to do the same thing for sine. So sine is over h, O is y, h is r, so y over r. And again, they want us to write, y equals this time, not x, so please correct that. Y equals, so we need to get rid of the r on that side, multiplying both sides by r, this cross out, y equals r sine of theta, r sine of theta. All right, and these formulas we are going to use. So let's do the math. If it wasn't something we could quickly graph to see that it was 0, 3 in rectangular form, how would we convert polar into rectangular? All right, so we know that x is equal to, where is it? R cosine theta, right? So x is equal to r cosine theta, right? What's r? So remember, this is r and this is theta. All right, so x is equal to r, which is 3, cosine of theta, which is pi over 2, right? All right, so evaluate what this is. What is cosine pi over 2? All right, so we know pi over 2 is over here, so it goes 2, 3, 4, skip 5, 6. So pi over 2 is here, and we know that this is always cosine as x, sine as y, and this is the point 0, 1, so 0, 1, yeah. 0, 1 from the unit circle. So cosine of pi over 2 is 0. 0 times 3 is 0. So x is equal to 0. So just evaluating the unit circle. All right, what about y? We know that y is r sine theta. Okay, so y is equal to the radius, which is 3, sine of pi over 2. We know that sine of pi over 2 is 1. So this is 1. 1 times 3 is 3. So this is equal to, y is equal to 3. So now writing it in terms of x and y. So x is 0 and y is 3. And you see that you get the exact same Cartesian coordinates or rectangular coordinates. All right, so that's how you transfer polar into Cartesian coordinates. You use these formulas to make it work. All right, so let's take a look at some examples. All right, example 2. All right, graph this, then convert it into rectangular form. All right, so let's graph it first. So you've got pi over 3, so it goes 2, 3, and then so this is my line. So it's going to be somewhere on this one, and then it's that. So it's somewhere on that line, and I need 5 pi. So this is 1, 2, 3, 4, 5. So it's on this line, and I know that also if we did the shortcut, this is plus 1 here, minus 1 here, and then this is $5 at 7-Eleven, right? So it works. This is the one I'm looking for. Positive means I go this way, so I'm in the right quadrant. And then I need 2 radical 3. So just go ahead and put that in a calculator, which is 3.464, blah, blah, blah. So I'm in this quadrant right here. Positive 3 is I stay there. So 1, 2, 3, and 0.4 somewhere around here. So that's plotted it. All right, let's convert it into rectangular form. So these are the two formulas that I need in order to convert it, and you need to go ahead and highlight it so that you know where it is. Those are the two formulas to get x. I use that one to get y, use that one. So let's find x first. So x is equal to the radius, which is 2 radical 3. All right, then cosine of theta, which is 5 pi over 3. And I'm just going to go ahead and write out what y is as well. So y is equal to the radius sine of that. So 2 radical 3 sine of 5 pi over 3. Okay. Now I have my x and y. We just need to evaluate it. So what is cosine of 5 pi over 3? So this is what I mean by you need to know your unit circle pretty well. All right. So it goes 2, 3. So it's over here. And we just graphed it. So this is a good thing. What is this? What are these coordinates? Because this one's going to be cosine and then sine. What are these coordinates here? So again, you take your left hand. Let's just do a quick review. Take your left hand and it's one finger. So I put this finger down. So the first one is 1/2, right? So this one here is going to be 1/2, and this is going to be radical 3 over 2. Okay, which means the one down here, they're the same numbers, but it's positive x, negative y. So positive x, negative y. Okay, so you do need to know your unit circle pretty well to work these out. All right, so cosine is 1/2. So this is 1/2 times this. So this is going to be x is equal to 2 radical 3 times 1/2. And y is going to be 2 radical 3. Sine of that, sine is negative radical 3 over 2. So just put all of that in the calculator. You're going to get x is equal to radical 3 and y is equal to negative 3. Okay, just put it in the calculator. So if I write it in my rectangular form, I write x first, radical 3, and then y, which is negative 3. All right, so go ahead and try this example using the same method. Now, let's practice.